Hey, so I'm going to take a break from the ViZDoom and the complicated 3D stuff and try some simpler things. The reason is the complicated ViZDoom costs quite a lot to train. You might say it's only $8 a day per instance, and yeah, $8 for one day is only $8, but then right now I've got two instances running, so that's $16. So for a whole month, that's like, I don't know, like $480. Which is kind of okay, but I want to run another experiment. I can't because I'm already using two instances. So I run another instance, then we're up to like $750 a month. So I'm going to try some simpler things. So I'm going to start with mounting car, I think. So mounting car is pretty interesting. So you have this car here, and the state is basically the position and velocity. Like someone says, all right, observation state. We've got the position of the car and the velocity of the car. And as far as actions, we can accelerate to the left, we can cruise, just like keep going at the same, like we don't accelerate, right? So if we're on the slope, that doesn't mean we're going to not move, we're going to gradually accelerate downwards from gravity, right? But we're not going to like accelerate from the engine of the car and this will accelerate to the right. Now the reason this is interesting is if you try to just accelerate to the right, the car will get to about here or somewhere, and then the force of gravity will overcome the acceleration of the engine and the car will get stuck. So you basically have to like swing backwards and forwards. Right, now this is hard. That's one reason why it's hard, right? Because you have to like realize to swing backwards and forwards. The other reason this is hard, if you don't use reward shaping, which I'll come back to in a sec, you only get a reward here. Right, so now imagine we use policy gradients. Now policy gradients, we're going to get a reward at the end of the episode if we get here. Right, but policy gradients, initially, it just does random stuff, right? So it'll just randomly move down here. It's just going to like oscillate. It's like sort of like brown in motion. It'll just be oscillating at the bottom. Like it's basically almost never going to get to the top. Like the chances of it getting to the top is sort of like the chances of all the air in your room all flying over to one side. I mean, it might happen occasionally, but not very often. All right, so actually the chances of getting to the top are significantly higher than the chances of all the air in your room suddenly rushing to one side. But they're not good. So it's interesting. That said, we have to be careful when we look at. So I was like looking at like what other people have done for this. I think for YouTube, it doesn't really matter whether I figure out stuff myself. What matters is don't make an interesting video, right? So I'm just going to like look around a bit and see what other people are doing. I mean, I'm going to mix it up because I want it to be fun for myself, and it's not fun for myself if I just copy what other people are doing. So I'm going to mix it up a bit, right? But I'll do sort of a mixture. Anyway, so I mean, the first two things I Googled, so they'll say like this one, for example, right? I mean, it just like came up in the top of Google, and it's like, all right, so we're using DQN, and it will train in 6 minutes. Like, okay, that sounds cool. So let's have a look. And now, if I have a look at this, I'm pretty sure that they are tweaking the reward down here. So new state 00, this is the position. Basically, if the position is more than 0.5, they get an extra reward. So they're not just rewarding the agent when it gets to the goal. They're rewarding. I'm not sure where 0.5 is. Like maybe it's here. Like they're giving an additional reward to the agent if it's getting like over here. So that is some reward shaping. It's an extra reward. Now you can take any environment and with an appropriate reward shaping, you can make that environment significantly easier. And I feel that reward shaping does make this much easier. I don't want to use reward shaping. I will if I have to, but I'm pretty sure that I tried this a few years ago and I didn't use reward shaping. And it works. You can solve it. I can't remember how I was doing it. I think I was using a tabular method. Now I want to use neural methods, not tabular. But I mean, I might start with tabular. I'm just going to do whatever seems fun and entertaining at the time. All right, so and then this one, here's another one. Like this is another one that's come top of Google, and it's like whenever the flag reaches the flag, it will receive a big reward. However, we don't want to reward the model only when it reaches the flag, as this would make it difficult for it to learn. Well, yeah, it will make it difficult for it to learn. Agreed. We can also reward the agent each state. So they are also doing reward shaping, right? So when we look at other people solving this, if they're using reward shaping, it's a much significantly easier problem because they don't have to deal with the challenge of only being rewarded here. But now what I think is, so I'm going to try different techniques on this. I'm going to use this to compare, I intend to try Q-learning, policy gradients. So I think policy gradients is, it will learn eventually, but it might take years, and I can't afford to spend years on instances. So I'll probably just leave it for a while and then be like, well, look, it's not learning. And then Q-learning might be able to, basically what we might want is some sort of curiosity, because imagine as a person, you're down here, you don't know about this reward. The agent doesn't know that it gets a reward for getting out here. It doesn't know that. Now you as a person down here, you'd be like, well, this is fun, I can swing backwards and forwards. So you just swing backwards and forwards for fun, right? Curiosity. There's a lot of papers about curiosity. I think curiosity is a powerful concept. This concept has been around for probably decades, actually. I think Schmid-Uber started off with some stuff about curiosity. And then it's been big in iClear. It was certainly big. I went to iClear for a couple of years before lockdown. And curiosity was really big there. OpenAI, DeepMind, they were all doing curiosity things, especially for Atari environments. And there's that game where you have to, you've got to collect keys to go to doors and all that. It's very hard. And curiosity, obviously, curiosity helps solve it, because you're like, oh, I've got a key. That's fun. But you'll get the key just because of the fun of getting the key. The agent will find that. And it doesn't have the concept of fun, but it's like, oh, this is new, let's try that. And so I feel like in the worst case, we can use curiosity to solve this without needing reward shaping. Maybe Q-learning can solve this anyway, I'm not sure. Maybe not. I think we need curiosity to solve this. Because Q-learning also needs to get some reward at some point. And Q-learning is not going to magically get up here just by moving randomly. And Q-learning will move randomly until it gets a reward. So actually I think Q-learning and policy gradients both cannot solve this without reward shaping or some curiosity. But I remember I solved this many years ago. If you read the Barton Sutton book, which it did, it gives a way to solve this, and it wasn't using curiosity. Maybe it was using curiosity. Maybe it was a tabular environment. I'm going to check what it is, right? I think maybe it was curiosity, it just wasn't called curiosity. I think maybe it was a tabular environment, and you had to go to every cell or something like that, which is curiosity, right? Right, so anyways, this is my goal. I'm going to try to solve mounting car. I think this is not going to need that I spend $500 a month on instances. Hopefully this stuff can just run quickly, and it will let us try cool and fun things. There's variations we can try on this right there. Think about the Doom environment. Right, now if you go back to the ViZDoom, there's an environment called My Way Home. And in My Way Home, you're in a maze. And so your point of view is very local. You just see what's ahead of you and to the sides. You don't see the whole maze. And I kind of want to start investigating, solving things like that. Or Doom, when you're playing Doom in general, you only have a local view. So technically it's called a partially observable, right? Partially observable MDP or whatever. I kind of want to start looking at partially observable things, but again, I want to keep it simple. So we can make this partially observable, right? At the moment, by default, the agent sees position and velocity. Now, velocity is local. You're sitting in a car. If you only see the stuff near you, you know how fast your car is going, even without being able to see things far away. But the position, that is a global thing, right? The position is a global thing. But the thing is, instead of giving position, what we could do is imagine if, let's say the car's here, we can give it the height of the line just in front of it, and the height of the line, the relative height, right? So compared to our height, the height of the car, we give the relative height of the line just ahead of it and the relative height of the line just behind it, those two heights. And that way the agent knows the slope. They don't know the position, but they know the slope. The slope correlates with position, but not perfectly, because the slope is the same here and here. But that doesn't matter actually, because you would do the same thing in either place if you were going the same velocity. Right? If your velocity is towards the right, you want to accelerate towards the right. If your velocity is towards the left, you want to accelerate towards the left. Like, that's how you do the resonant thing. So I think that would be kind of fun. So basically the agent can only see the stuff next to it and its velocity. So then it becomes partially observable, which I think is fun. So this is my plan. I'm going to try to solve mountain car with a few different methods. I guess I'm going to start with policy gradient because it's super easy. And I guess that's going to fail. But I don't know. I'm going to try it. It will depend on the configuration, right? Like, if this is sufficiently low, then the policy gradients can solve it randomly. If this is high, or like the acceleration is low, then it's just going to get us stuck down here. It might solve it by the time the Earth crashes into the sun, but not before it. Cool. So that's my vision. I don't know. Maybe I'll just put this on YouTube as my vision, and then we'll see what happens. Cool. So if I put this on YouTube as my vision, and you got this far, then thank you for listening. Any comments, suggestions, ideas, please put in the comments. I mean, I don't get any comments, right? So if you put a comment, that will make my year, because first comment for like, well, I had a comment like about 2 weeks ago. It's literally like one comment every 2 weeks. Yeah, so anyway, please feel free to put comments. I mean, I encourage you to put comments about what you would like to see, what is fun for you, what you're looking for. Like, are you looking for code? Are you looking for like trying simple environments, complex? Are you looking for me to spend like $1,000 to train something for ages? Like, just like whatever you're interested in, please consider putting this in comments. You know, I should put this at the start because no one ever gets this far. If you've got this far, congratulations, you're probably the first person who's ever watched one of my entire videos. Cool. All right, so in that case, thank you very much for watching this far, and hopefully you'll watch more of my videos, so see you.